All right, we have here a depth gauge. Depth gauges are used to measure depth. This one has a special foot on it. It is very specialized. It is used to measure rivet height gauge. So we've added a foot to measure it against. Now, there are a lot of different types of depth gauges used for a lot of different applications. But this will work well for us. Now, you will notice that the needle moves quite freely on here. And a depth gauge will measure in thousandths of an inch again. It says so right here on the dial. It says 1,000th of an inch. You can see that. Now, for our purposes, what is interesting to note is the way this is set up, you can have a negative number. This is the first time that you've been able to have a negative number. To zero a depth gauge, we will set it on the plate. And I, of course, would normally do this standing up, and then I will turn my dial so it reads 0. We loosen this screw, adjust the dial accordingly. This is going to be a little bit hard to see, okay, because we're on here, but you will see what I want you to see. Now, once again, look at the needle. If that needle is right there, I'd say we are at, I'm sorry, it's not locking, but right about there is 9,000th above. If it was down, that is not 84 thousandths above. That is, anybody want to take a guess? 17 thousandths negative. Okay? So when we measure on a plate, even if you do not zero every time, what you are measuring is the needle swing. I really don't care if you zero it or not. You can. It's a little tedious because the metal moves quite a bit. What I care about is how far the needle swings from outside the fastener to inside the fastener. On this plate, we have countersunk fasteners. And on a countersunk fastener, we check the head height. So what we're going to do is I'm going to put my tool beside it. Right now I'm at -2. I roll over the fastener. When I'm at the center of the fastener, I am now at +2. -2 plus +2 means 4. We are 4 thousandths high. If I had zeroed it and we were at 0 before I started and it moved up to 2, what would we be? 2 thousandths high. It's about how far the needle moves. Now, when we measure fasteners, we are measuring to the center of the fastener. Okay? So we have a fastener in this hole. And we are measuring the center of the fastener. It is possible for you to be in specification at the center of the fastener and out on the edge. It's a different condition. That's called a non-shear condition, where one part of the countersink is deeper than the other part of the countersink. It's usually caused by a crooked hole. But for this tool, we are measuring one thing, and that's the height of the rivet head, and it's always measured at center. At WATC, fasteners are installed to the following spec: 0.001 to 0.003. So for a fastener to be in spec, you must be between 0.001 and 0.003, between 1 and 3 thousandths. If you are anywhere outside of that, then you are outside of spec. So if you have a fastener that is negative 0.001, you would be out of spec. Negative anything is out of spec. If you had a fastener that was 0.005, you would be out of spec. It is incumbent that you pay attention to this. All right, so once again, you can see this. I am beside my fastener. I am at -2. I move to my fastener, and now I'm at +1. That leaves me at what? 3 thousandths. 3 thousandths is in spec. Okay.